I have this sketch here which I enlarge, and I hope you also have it. If you don't have it in front of you, maybe you can quickly just draw it. I'll keep it on the screen while I read the information. So what do you do in geometry? I don't just go and look at the sketch and try and figure out the values. You can see you're going to find A, B, C, and D. I first go and look at my information, because my information is so important. The information helps me to get to my answers. It helps me to get to my solution. It says there in the diagram, P, Q, R, T lies on the circumference of the circle. P, Q, R, T lies on the circumference of the circle. I stop immediately. Grade 12s, why? Because this is the theorem that is pasted on my walls. Remember grade 11 when I was in grade 11 and I did that? So why do I stop? What is so important? They just told you something so important. They told you that P, Q, or T is on the circumference of a circle. What does this figure then tell me? P, Q, or T. P, Q, or T. What is this, grade 12s? This immediately is a cyclic quadrilateral, because the definition of a cyclic quadrilateral says all 4 points lies on the circumference of the circle. So this is a cyclic quadrilateral. What do you know about the cyclic quadrilateral? This is what must be on your walls, or posted on your mirrors, or your fridges, or wherever you have a space. What do you know about a cyclic quad? I know 2 things. I know that the opposite angles of a cyclic quadrilateral add up to 180. So angle Q plus angle T is 180. That means R plus P is 180. That is what I know. The opposite angles of a cyclic quadrilateral is 180. It's supplementary. And if an exterior angle is drawn, if you draw an exterior angle, New Orleans High School, the exterior angle is equal to the opposite interior angle. I cannot start the sum without knowing this. The exterior angle equal to the opposite interior angle, and the opposite angles are supplementary. I know that. Furthermore, I see something so significant. They are telling me that MW is a tangent and that TW is a tangent. So TW is a tangent and MW is a tangent. Now I take another piece of paper. We are busy with this. We just finished it at our school. We just finished tangents with the grade 11s. Now grade 12s, what do you remember about tangents? Again, I remember 2 things. If I have a circle and I draw a tangent to the circle, remember tangent comes from the outside, only cutting your circle once. The first thing that I look for is a radius. The minute I see a radius, I tell myself, okay, the angle between a tangent and a radius is equal to 90 degrees. That is if I see a radius. But if you look at our sum this afternoon, I don't see a radius, but they gave me tangents. So what am I to look for? Right? So the next thing I look for, and that was on my wall, was if I have a tangent, right? And I don't have a radius, I look for a chord. There where the tangent and the chord meet, I see that it forms an angle. So it's tangent, chord. And after I found my chord, I look for a triangle that goes to the alternate segment. That means the other segment. There was a student in my class who drew it this way the other day. No, if this is the angle between your tangent and your chord, then your alternate segment is this way. So the theorem says the angle between a tangent and a chord is equal to the angle in the alternate segment. So this angle will be equal to that angle there. If I draw my tangent from the other side, say for instance, I do that. Do you see a radius? No. You look for a chord, and that is the angle between the tangent and the chord. And once I found my chord, I look for a triangle. Look, look, look. That goes to the circumference, and these two will be equal to each other. Are you good with that, everyone? So when I see a tangent, I look for a radius because this angle will be 90. If I don't see a radius, I look for the angle between a tangent and a chord because it is equal to the angle in the alternate segment. Tangent and chord equal to the angle in the alternate segment. Remember, this triangle must go to the circumference of the circle. This triangle must go to the circumference of the circle. Right. Now, can you see, grade 12s, how much theory you need to know in order to tackle a sum? You can't just go and do geometry like I tried to do in grade 11. I need to know my theorems. And with that, we can now tackle the sum. If you know what the answers are to A and B and C and D, then you can send through your answers. Really, it is no problem. Okay, let's look at our questions. Okay. Right, I have some questions here on the WhatsApp group. So I'm quickly going to leave the sketch here while you guys tackle it quickly. Try and find, after all of this, they say find the size of A, B, C, and D. If you know what the answers are, I'm going to keep the sketch here. You can WhatsApp your answers through to me. Somebody's asking here, let me just see. Everybody is just saying that you are tuned in and you're ready for the broadcast. That makes me very happy. I'm going to go back later to question 1.3. The person that sent what is 1.3 question, I'll go back to that. I just want to see 1.3 here for the previous question was just you had to determine the length of the radius. The person who sent in that question, that is, you just had to determine the length of the radius. Right, grade 12, I'm getting answers already as to what the sizes are. And I'm so excited. Some people are sending in answers here and they typing. The one student who said that A is 41, and I can't see your names, but the one student who sent in that A is 41, don't you just want to look again? And then the person that sent in that A is 29, awesome to you. All of you, try your best to get these sizes now. Okay, so now they say this angle from here to here is 75. This angle is 29. This angle is 34. And we must find A, B, C, and D. Just remember that C just goes from here to here. Okay, grade 12s, C just goes from there to there. Right, are you ready?